What's up, RKT team? This is Noemi. Welcome to my first lesson, and today we're going to be looking at logarithms.
So, what are logarithms and how do we use them? If I were to say to you that 3 squared is equal to x, I'm hoping that you can try to figure it out. X will be equal to 9. What if I say x to the power of 2 is equal to 9? Well, you can probably also figure it out by taking the square root of both sides, which gives you the answer of 3. Now, it could be positive or negative, but in this case, we're just going to assume that it's a positive value, which is going to lead me to this. 3 to the power of x equals to 9. Well, because we already looked into this number, you can probably tell me, but what if this was a question where x wouldn't be some nice positive integer? For example, 3 to the power of x equals to 29. If you want to solve for an unknown power, we actually have to convert this into a logarithm. And the way we can do that is we write this as log base 3 of 29 is equal to x. Converting it into a logarithm, we can now solve for x. You're going to plug that into your calculator and you're going to find out that x equals to 3.06 something.
So I hope you know a bit more about what logarithm is now, and let's look at some examples.
If ln 3 of 100 equals to ln x, is the value of x bigger or smaller than 100? To solve this equation, we're going to first express both logarithms in the term of a common base. We're going to rewrite this on the left side using the change of base formula, which is found right here. We're going to rewrite log base 300 to ln 100 over ln 3. Step 2, we're going to plug this in back to the formula so it equals to ln x. To solve x, we need to exponentiate both sides of the equation to cancel out the natural logarithms. So here we're just going to simplify it a bit further. E to the power of ln x will just be x, is something you have to remember. And we're going to divide ln 100 over ln 3, and that will give us the number of 4.19. Using a calculator, x is equal to 66.26. And that means that A is the correct answer for this example.
Okay, let's look at our second example. Here we have the expression of log of 1 plus log of 1,000. Let's break it down. First, we're going to be handling log of 1. The logarithm of 1, no matter the base, is always 0, because any number raised to the power of 0 gives you 1. Next, we're going to look at log of 1,000. Here, by default, if the base is not mentioned, we use the base of 10. What power do we need to raise 10 in order to get 1,000? The answer is 3. So log of 1,000 equals to 3. We add them up together. It'll give us our answer is 3. Easy, right? So let's move on to our next example. To solve this, we're going to be using this very useful logarithm rule right here. You can pause this video so you can try to solve it yourself. So in our case, A equals to 4, B is E, and C is 64. So just by plugging our numbers into this rule, we're going to get our final answer, log base 4 of 4 to the power of 3, which then gives our final answer, 3. So here comes our last example for today's video. This question is a tiny little bit trickier than the ones we had before, but don't hesitate to pause the video so you can first try it out yourself. To find the value of t, we first plug s in the equation, and we're going to simplify this cube root into the power of 1 over 3. After that, we're going to apply that number and times its original power minus 1 over 2. We then get the power of minus 1 over 6, and as we know, we can pull that in front. So the original expression becomes minus 1 over 6 times log base 2 of 2 to the power of minus 1, which then, using the rule that says log base b of b to the power of x equals to x. In this case, the base of the logarithm and the base of the exponent are both 2. So we're going to pull that minus 1 in front, and our final answer will therefore be 1 over 6. Voila!
Thank you for watching this video. I hope this video helped. If you have any other questions, remember that my DMs are always open.